So today you're going to find a value of x when given the proportion, or also known as the area. This is also called inverse norm. So back on page 7 of this homework packet, we were introduced to Frank, who wanted to be accepted into a prestigious study abroad program. In order to be considered for the program, each applicant took an entrance exam. The mean score for all students was 79%, with a standard deviation of 5.9%. If the program only accepts applicants within the top 5% of scores, what score would Frank need to be accepted? So let's highlight some of the things that this problem is telling us. First, we know that the mean score is 79%, and this is the mean for the entire group of students who took this, so it is a population mean and we use mu. We also know that the standard deviation of all the students is 5.9%. That is sigma. We're also told that in order to be in this program, applicants have to be in the top 5% of scores. With this information, we know that we can fill in a normal distribution. Our center is the mean, 79%, and then we fill in the rest of our curve using the standard deviation. We also want to make sure we include our label. This is the score on the entrance exam. So the scenario states that only the top 5% of scores are accepted. So let's shade in what the top 5% would be. So we know that the tail is about 0.15, and then the next section between 2 and 3 is 2.35, so that's 2.5%. So it has to be a little bit to the left of the second standard deviation. So this is approximate. So this is top 5%. And we need to figure out what score is going to get us in that region. So we're looking for the x value, something between 84.9% and 90.8%. So in this problem, we're working backwards. Before, we knew what the x value was, we knew what the data point was, and we found the percentile. Now we know what the area is, and we need to find the x value that get us there. So before, we would use the z-score formula to calculate the z. We would sketch the distribution and shade the region that we were looking for. We would then go to our z-score table and locate the area that corresponds with the z-score. And then we would record that area. So working backwards is going to go something like this. When we're actually looking for the data value, because we know the area, we start with a sketch. Then we find that area in the z-score table. We record the z-score that corresponds to that area, and then finally we use our z-score formula to find x. So essentially we're working backwards from the problems that we've done previously. So we know that the z-score table only records areas that are to the left of a given value. So being in the top 5% means that you're actually in the 95th percentile. So we're looking for, in our z-score table, we're looking for the values to the left. So to the left of our shaded area is 0.95. So the area that we need to find in the z-score table is also 0.95. So I go to my z-score table, and I know that the outsides are the z-scores, but all the numbers on the inside are the areas. Which area in the table is closest to 0.95? Well, there's actually two. 0.9495 and 0.9505 are both equidistant from 0.95. They're both 0.005 away. So when this happens and you have two possible z-scores that are equidistant from the area that you're looking for, we average them. So the z-score that corresponds to 0.9495 is 1.64, and then the z-score for the other one is 1.65. When we average these together, that means that you would have to have a z-score of 1.645 in order to be in the top 5%. But we want to know what test score. So we have to go back to our z-score formula. We now know that the z that will give us a top 5% is 1.645. We know the average of the group is 79, standard deviation is 5.9, and we are looking for the data value. What is that test score that's going to get us there? So here's our z-score formula, and I substitute the values in. So this is algebra 1. In order to find out the value of x, I have to multiply both sides by 5.9. Then finally, to get x by itself, the inverse of subtracting 79 would be to add 79. So I get a value of 88.7%. Does this make sense? Well, let's go back to our picture. I can see that the shaded area starts somewhere between 84.9% and 90.8%. So does it look like 88.7 is a logical solution? Yeah, definitely. 88.7 falls between that range, and it's pretty close to the 90.8, so it looks like that's a pretty good estimate. This means that in order for Frank to get into the program, he needs to score at least an 88.7% on the NCLEX exam. Here's one more example. After their most recent vet visit, Ms. Hammond was informed that her dog Shadow, look how cute he is, was in the 70th percentile of weights for dogs his height. After a little internet reconnaissance, she found out that the mean weight is 32 pounds with a standard deviation of 2.7 pounds. How much does Shadow weigh? On an AP exam, if you get an open-ended question like this, we have to follow our 4 steps. So the 4 steps begin with state. What are we looking for? What information is given? We want to make sure that we're defining any variables that we're going to be using. So let's first see what we know in this problem. We know that Shadow's in the 70th percentile. That's an area. We know that the mean for all dogs his height is 32 pounds. That would be a population mean, so that's mu. And the standard deviation for all the dogs his weight or his height is 2.7 pounds, so that's going to be sigma. In this problem, we're going to say x is the amount that Shadow weighs. We want to find the value of x at the 70th percentile for a normal distribution with a mean of 32 pounds and a standard deviation of 2.7 pounds. This statement is something similar to that is what you would need to write on the AP exam to receive credit. You need to tell the testers what you're looking for, what information you have. So with this information, we know we can fill in a normal distribution. So we have to make sure to include our labels, dog weights, and I made sure to include that in pounds. We know that the mean is 32, and the standard deviation will give us the rest of the data. This time we know that Shadow is in the 70th percentile. 70th percentile means that 70% of dogs weigh less than Shadow. So I approximated, I know right down the middle at 32 is the mean, so that's 50%. And then I shaded a little bit to the right because I know that area between 0 and +1 standard deviations is 34%, which would take the total shaded area to 84, and that's just too big, so I know it had to be less than that. So this is an approximation. This is what I think 70 percentile would look like, so the area here is 0.7. So we're trying to figure out what value would have to be x in order to make this happen. So looking at our picture, we know that it's got to be somewhere between 32 and 34.7. So 70th percentile. The closest number to the 70th percentile is 0.6985. That is only 0.0015 away from 0.7. Whereas the other one, 0.7019, is 0.0019 away from 0.7. So the z-score we want to use is 0.52. So we know the z-score, we know the average of all the dogs in the population, we know the standard deviation, and we are looking for the value of x. Here's our z-score formula. I substitute the necessary values, and with my algebra skills, I know that I have to multiply both sides by 2.7 to get rid of the denominator. Then finally, to get x by itself, the inverse of subtraction is addition, so we add 32 to both sides. And it turns out that Shadow probably weighs around 33.4 pounds. This makes sense because if you look back at our picture, we know it had to be between 32 and 34.7. So in conclusion, we want to make sure that we are putting our answer back in context. So in order for Shadow to be in the 70th percentile of weight for dogs, his height, Shadow would have to weigh approximately 33.4 pounds.